So we've been talking about these compound angles in drilling through a material. We're going to continue that today, only we're going to look at it a little bit differently. Today, rather than being given the dimensions, we're going to be given angles. Up to this point, what we've been given looked like this. Where we were drilling from this corner to this corner, and what we were given were the dimensions. We might be told that this is 1¼ inches thick. This here is 1 inch wide, 1½ inches this way. And we use that to find this angle here, which is our angle of rotation, and this angle up here, which is the angle of tilt. Well, what we're going to use today, rather than the dimensions, are the angles. What do I mean by that? Well, if I look at this here from this side, its projection would look something like this, that hole going through it. So I'm going to look at having this angle here, which I'll call angle D. And then if I look at it from this side over here, the projection of the hole would be something like this. And then I have this angle here, which I'll call angle B. I can find all the other angles from those two angles without a whole lot more difficulty than what I had before. What I have to do is, even though it's not given, actually in this case it was given up here, but let's pretend we don't have any of those measurements. What I can do is I can just take a measurement to be my thickness right here. And I'll take a measurement that happens to be an easy one to use. Maybe it's 1 inch, maybe 10 inches. It doesn't really matter. Or millimeters if I want to do 10 millimeters. What I'm going to do is I'm actually going to use the 10 millimeters. So what that dimension would be, that would be this height here, 10 millimeters. That thickness. Now this dimension here, which would be this one here. From the 10 millimeters, how would I find that? Well, I have to know these angles in here. Let's see, I'm given that this angle here is 36 degrees, and this one here is 58 degrees. This side now is, the 10 millimeters goes here. This would be a right angle here. This is the opposite side according to that angle. This is the adjacent side, which means I'm looking at a tangent. Definition of tangent is tangent of an angle is opposite over adjacent. So I fill in what I know. I have the angle is 36 degrees. The opposite side is what I'm looking for. The adjacent side is the 10 millimeters. So now I solve for that opposite side. I can do this and cross multiply and divide. It's 10 millimeters times the tangent of 36 divided by 1. Gives me 7.26. I would go 265. So this dimension is 7.265. Millimeters, you're right. Thank you. Now we got to do the same over here. This is the 10 millimeters here. This is going to be the opposite side. So the formula looks exactly the same. Only its tangent of 58 degrees equals that opposite side over 10 millimeters. Put that over 1. We're going to cross multiply and divide. So it'll be 10 times the tangent of 58 divided by 1. 16.003 millimeters. Now that I have those 3 dimensions, I can go back to finding the angles. Now you might be asked, well, what if this isn't 10 millimeters thick? It doesn't matter. It's going to be proportional. You can put any number here for the thickness. And as long as you calculate these appropriately, it's going to be similar to the original piece. And remember, the thing about similar objects is the sides and lengths may be different, but all the angles are exactly the same. And that's why we can just pick whatever number we want to use here, is because the angles are going to be the same. Even if it's really smaller or larger, the angles are still going to match up. So we can pick whatever size we want there. So now we can find this angle of rotation here, because it's going to be the inverse tangent of the 7.265 over, perfect, 16.003. Second tangent, 7.265 divided by 16.003. 24.42 degrees. Next, we'd have to find our length of cut here, the length of that diagonal. How do we do that? Well, that'll be the square root of 10 squared plus 7.265 squared plus 16.003 squared. Gives us 20.22221 is that length. And now we can find the tilt here, this angle of tilt, because that angle of tilt is going to be the inverse cosine of the height, which is the 10, over that length of cut, 20.221. Gives us 60.36 degrees. So that's our angle of tilt right there. So you can see it's not that much different from being given the lengths. You just pick a thickness and you use that to find the other dimensions. Let me do one more example for us here. One more is about all the talking I think I'll be able to do today, so. So let's draw out our diagram here again. So we're looking at this again. The projection from this side would look like this. I'm going to give you that this angle here is 51 degrees. Projection from this end, I'm going to give you that this angle here is 42 degrees. And once again, we're looking for the angle of rotation and the angle of tilt. So we're going to go ahead and pick a thickness. It can be whatever we want to. I'm going to pick 10 millimeters. So that means this distance here, or so I'm going to label that up here. This is 10 millimeters. This distance here is going to be found using the tangent. Tangent of 42 degrees, if I call this y, is going to be y over 10 millimeters. So, oops, wrong button. It's going to be 10 times the tangent of 42. 9.004. Over here, we do the same thing. This is going to be the tangent of 51 degrees equals, if I call this x, x over 10 millimeters. So that'd be 10 times the tangent of 51. 12.349. Millimeters. So that goes right here. So now if my angle of rotation here, this angle here is the inverse tangent of 9.004 over 12.349, which will be 36.10 degrees. So that's my angle of rotation. To find my angle of tilt, I first have to find the length of cut, which will be the square root of 10 squared plus 9.004 squared plus 12.349 squared. Plus 12.349. There we go. So 18.264 millimeters. That is the length of my cut across here. Finally, my angle of tilt. T is going to be the inverse cosine of this height here, which is the 10 millimeters, over the length of cut, which is the hypotenuse of 18.264. So second cosine 10 divided by 18.264. 56.80 degrees. So there's my angle of tilt. Now your packet does give you a shortcut for calculating these. I'm going to change it a little bit. R, the rotation, is the inverse tangent of angle D divided by the tangent of angle B. But remember, D is the side view and B is this end view. T, your angle of tilt, is the inverse tangent of square root of tangent of angle D squared plus the tangent of angle B squared. That will work out. Let's try to use those formulas on what I just did up here, where I had 51 and 42 degrees for D and B. So D is 51 degrees, B is 42 degrees. So my angle of rotation would be the inverse tangent of tangent 51 over tangent of 42. So I do second tangent. Now in the parentheses I do tangent 51. I have to close the parentheses, divided by tangent of 42, and I have to close the parentheses twice. It spits out 53.90. Now you'll notice that's not what we had up here. We had 36.10. I probably had the two angles in there backwards. This is the complement of what we had. 90 minus that would be 36.10 degrees. That just means I switched D and B when I used them before. Angle of tilt. T is going to be the inverse tangent of square root of tangent 51 squared plus the tangent of 42 squared. Now this one, a little trickier. Second tangent. Now inside the tangent, I'm going to hit second square root. Now I've got to do tangent of 51, close the parentheses, and then hit x squared, plus tangent of 42, close the parentheses, and then hit x squared.
You only put in a 2.
Again, for some reason it doesn't. And then I have to get outside my square root to close my parentheses again. I get 56.80, which is the same angle of tilt I had before. 56.80. Make sense? No? Did this part up here make sense? Yeah. These formulas don't make much sense. I mean, I could go through and show you where the formulas come from. You'd still have to memorize them.
How did you get that 53.9?
This here?
Yeah.
That was just, this formula here is the inverse tangent, so second
How did you
tangent.
know that answer needed to be subtracted from 90 to get
The only reason I knew that that had to be subtracted from 90 is because I had figured it out up here. I had already found the angle of rotation up here, doing it my way. The other angle of rotation would have worked here. That would have just meant I used this side up against the bottom instead of this side. Either angle of rotation would work. The difference is when I put this on the drill press, the way I figured it out here puts this short side against the bottom, and we're rotating off of that. Like this. So that's our rotation. The way we figured it out down here puts the long side up against the edge. And then we're rotating that long side off the edge. Like that. Either way it'll work. It's just that the two angles of rotation will be complements of each other. Either way gives you the exact same angle of tilt. It's just how you set it up, which edge you want to use as your reference edge. Whether you want to use this edge or this edge to run your rotation off of. in your packet. Page 401 to 404. I realize I should have done another example or two, but my voice isn't going to take it. So I'll give you those to work on. Are those in this packet or do you need a new packet?